So we dragged against the lecture today. Had a nice day today, but unfortunately inside of the campus is quite silent. No chatting and no voice. And if you comparison with silence and much voice, I prefer much voice. Anyway, I'd like to ask you, dear, my voice is too small or too loud? If we have, yeah, I would love to have some comment about my voice. Please tell me by texting and too loud or too small, and I think I can control my voice. No comment, so dear. I understand, dear, my voice is not so bad. So today is 20th, Wednesday, May, and maybe you can hear my voice with some noise outside. That's not noise from the students, but I guess, air fighters. Maybe today is a day of the drill of the Japanese Air Force, and we can hear some fighters' noise, and I cannot stop it. And the file today we're going to use is this one, 2020, and Advanced Energy Chemistry, distribution for ZIL, and portable document format file. And you should download this file from this homepage. Yeah, I have already told that this is in full-time English, and reading will be also in English. And a textbook, I mean, this in my case, this is distributing papers written in English as well. And I would like to emphasize the following thing, that some English I'm telling you here is you have already studied in high school or junior high school, or maybe the beginning day of your university. So do not do not hesitate to do something, to pronounce and to listen to the English. You already have your knowledge and skills. So I'd like to have an attendance of yours. Send me your student ID, student number as attendance by the texting as usual. Then, yeah, every time I told that you need more than 80% of the attendance, and the credit of the lecture will be earned when more than 60% of the question answered correctly within the 2 examinations. But this is not really a real examination, but every time I have some exercise and assignment or something like that, that includes this examination. And yeah, so you're send me the message as attendance and with your student IDs. And the graduate students, I mean, you joining this lecture should better complete and submit any assignments and exercises, even if delayed from the deadline. So if their deadline has been gone, you you just complete and submit any of your assignments and exercises. Otherwise, we do not know you're attending and others, so your yeah, you should do within the deadline. But if outside the deadline, if late, even if late, you send me the assignment and exercises. And I have an announcement from the university that maybe I have already wrote to message, but maybe I'm also, you already have some information from the university, but all lectures at the first semester at present in Hamamatsu campus of 2020 will be held on demand or live via internet, unless otherwise noted due to the new coronaviruses. So you may understand that any of in this semester, we do not know yet the next semester. I think from October, we do not know yet, no schedule, that at least this semester, all lectures, especially for graduate students, all lecture will be held online or live as well. So maybe the next month, 8th of June, the general lecture will start. But it's especially for the freshmen. So we are going to make some space classrooms for the freshmen and other people, like especially graduate students, just have this kind of lecture, because freshmen need some 3 times more space for the lectures. We should avoid some packing and clothes or something like that. So we need more rooms for lectures. So maybe especially for graduate students, at the first semester, the lecture style is something like in this way, live or just on-demand lecture. This is my announcement. Schedule, first half, and second half will be given by Okuya Sensei and myself. Today is some 20th Wednesday, and accent and pronunciation of the scientific word especially. Agenda today is maybe not so much Russia, but just straight we're going to the accent and pronunciation of scientific words. Yeah, maybe this is my assignment from last time, the conversion from the degrees centigrade to degrees Fahrenheit, and maybe the vice versa, this way or this way. Vice versa is this way. Conversion is frozen. Equation follows. Yeah, quite a bit complicated. Yeah. So approximately 19 degrees Fahrenheit equals 32.2 degrees centigrade. So in United States, it's a hot day. Means around 19 degrees. So that means in Japan, it's 30.2. But the country still taking the Fahrenheit is just, I know, United States. In Canada, they're taking this one and something weight, same. Their Canadian uses gram or kilogram or liter, but in United States, they still use a pound or something like that. In some part in Canada, you can see some of them like dumbbells and barbells. Their weight is written in pound because it's an import or export from the United States. So in Canada, you can see above kilogram and pound, but yeah, only United States is quite different from other world. Yeah, maybe you can see this kind of the thermometer. Yeah, this side is degrees centigrade Celsius, and this side is Fahrenheit. So 100 degrees uh, Fahrenheit is close to 40 degrees centigrade. So we have done some punctuation, persons, singular and plural forms, as can tell the time, even numbers and scientific expression in English. But today is also some scientific expression, scientific words in English. Yeah, last week we have done figure and tables, units, numbers, decimal fraction, and fractions. Yeah, you should remember fraction and the decimal fraction. And the calculation, mathematical calculation we have done, just not math, but pronunciation, addition and subtractions, multiplication and divisions we have done. And we did power and root in the area and volume um, equations. So we just, last week we bit done, but we're going to see first today is round off. Round off is, yeah, this is often used in English-speaking country, and round off means something like this. 1.5753 is rounded off to 1.58 to 2 decimal places, something like that. So maybe you can ask people, round this number, please round off this number to 2 decimal places, or something like that. So 2 decimal places is here, 1 and 2. So you round off these numbers. Round off. Fraction again, I got some questions here. The specific name of, we have done this fraction. The pronunciation is, you may call this 3/8. 3/8 we have done, but I got a question. What is not specific, but the general name of this part and this part? Yeah, in fact, I did not know that. I have inspected the dictionary, and it said that this part, numerator, accent here, numerator, and this part is denominator. Denominator, you may call that general name of this part and this part. Number is 3/8, but the general word, this part is numerator, and this part denominator. Yeah, I don't think people do not use these words too much, but that's just that question. Maybe the next expression in mathematics or scientific world is proportion. Proportion is like, proportion is proportion, but in the mathematics or science, proportion is like, we are going back to figure, and something like that. This is example word. The current increases in proportion to voltage. So the current should be like this. The current increases in proportion to voltage, just in proportion, so this way. Yeah, there is some expression to tell the proportion. So these two relations, there's some proportion. The current decreases in proportion to the voltage is same. So the current The last time is this way, but now the current decreases. So the curve should be this way or something like this way. Never tell them this original point. So the current decreases in proportion to voltage is like this. Also, the current is reduced. It's same as degrees. Degrees is reduced. And in fact, here, degrees is some verb, intransitive verb, so you cannot make a sentence of passive voice. But this is an intransitive verb, reduces transitive verb, so you can make the sentence of passive voice. The current is reduced in proportion to voltage, so it's same this way. So you better have some lot of words, degrees or be reduced, indicating same means, same in means. So when you write a paper or something, if you use all the time same words, it looks like a bit silly. Oh, this guy is just from elementary school or something like that. So you better have the many candidates for which those words have exact same in meaning. The current is reduced in proportion to voltage. Yeah, this is same as well. The current increases commensurately. It's same. It's like just in proportion. Yeah, I think if you have this kind of question, it's very good. The proportion is this way, so the you might think the other side, the reciprocal proportion. Reciprocal proportion is like, oops. Reciprocal proportion is like inverse, you may call that inverse proportion. So the current, excuse me, increases in inverse proportion to voltage. Oops. This is the very much commonly used phrase. The current increases as the voltage increases. So it's never say the relation, maybe this way or this way or this way. It never tells, but at least the current increases as the voltage increases. So if this is temperature, the current increases as temperature increases or temperature elevates or something. So this as something, verb as, maybe something increase as increase or something decrease as increase or decrease. These phrases are very much commonly used as something. Right. Maybe next one is a bit advanced way. The current increases in an exponential fashion. So the case of exponential, you may call that in an exponential fashion. So I guess this way. The current increases in an exponential fashion. This is something from the, I guess, some English Wikipedia, and the red line is linear, and the green line is, as I told, exponential, and the blue one is a power, but a third power. So you may call that, it's for the third power or second power, but just in case of second power, you can call that squared. And maybe you can call this as cubed, but third power exponential linear, something like that. You may call this one. Yeah, something words and etc. Yeah, this is in short form kind of acronym, etc. These big letter, you may call that capital or capital letter. Big letters, you write big, and at the top of the sentence, you should use a capital. At the top of the sentence, you should use a capital. Or anywhere in the sentence, the case of specific noun, you may use the a capital. Like example is Mr. Yeah, this is capital Smith. Let's Miss, maybe Mrs. Smith. I'm sorry, but quite basic sentence, but anywhere in the sentence, in the case of specific noun, you should use the capital at the top of the word. Or all the time, at the top of the sentence, you have to use a capital. There is a road along the river, something like this. So here, all the time, you have to use capital at the top of the sentence. Oops. Oops. I'm going to show some this word. You do not pronounce the top letter of the word, especially related to science. So you don't pronounce top P, you don't pronounce as a top P, you pronounce this as pseudo, or this is psychological. So you don't pronounce this one. So pseudo means if you're going to talk about like chemical reaction, especially reaction rate, you may, if the reaction something like this, A plus B equilibrium, maybe not equilibrium, goes reaction AB, and this reaction rate is expressed with the following equation. So reaction rate is V, and this is coefficient, reaction coefficient, and this reaction rate follows concentration of a material. This case, maybe you may call that this is first order reaction. You may call this first order reaction, but we do not know yet about about B. Maybe reaction rate is described with this way: coefficient, concentration A, maybe B. We do not know yet. In this case, you cannot call this first order reaction. Instead, pseudo, first order reaction. Pseudo first order reaction. We do not yet about concentration B, so maybe this reaction follows maybe this equation. So that means second order reaction, but case like this concentration, this excess concentration for this. So in those cases, we do not know yet about B concentration. So you may call that pseudo first order reaction. Psychological is psychological, mental, or something. Next, a word, you do not pronounce the end of the letter of a word. I'm sorry, this is not A, should be the. This is a good example of their, it should be the. Example, you don't pronounce this B, right? So the like lamb meat and climb, yeah. In fact, here, in particular, I prefer the climbing, especially Canadian Rocky Mountain. I climb Rocky Mountain. Bomb. There is a bomb in the car, so it's a bomb. Comb. She is combing her hair. Comb. And thumb. So your all fingers, like looks like thumb. That means treating very bad. Your treatment is very bad. So that means your fingers are all thumb. Like this is function is lower than this part. So the thumbs, or maybe sometimes you may call that always someone could not catch something. So like you cannot catch apple or something like that, and you said you called oops. I cannot catch that. So those cases, you may call those people as you have batter finger. You have some batter, everything batter on your finger, something slippery, very much slippery. So here, thumb. Next example. Oops. No. A word, you do not pronounce the middle letter of the word. So this is some mistake. The like H, ledge. Pronunciation is, you should care about this pronunciation. Badge, so same pronunciation as cat. Lodge, wooden lodge, and badge. Those are examples. And exercise 1. Today, there are 2 exercises. The first exercise is as follows. Exemplify the 10 words in which you do not pronounce the top, middle, and, oh, it's something strange. Wrong, sorry. I am very sorry, but I get many mistakes today, and you do not pronounce top, middle, or end letters. Exemplify 10 words in which you do not pronounce the top, middle, or end letters. Exemplify 10 words in which you do not pronounce the top, middle. Yeah, so I think there's many examples of these words. Yeah, except these my examples. So yeah, like I should show you examples knife or eight. You can pronounce this verb. You can pronounce this or something like this. So just show me the 10 words, something like that. Top, middle, or end part. You do not pronounce. This is exercise one. We have two exercises today. And same, submit your exercise and do not submit, right? So as I told you, we have two exercises today via email. My email address is like this, and you have to give your student ID and the mail title, and you should also start with the student number, student ID, and your name in the main text. And attached file will not be accepted. The deadline is by May 20th, Wednesday today, 12:45 a.m. So no, not too much. I'm sorry, p.m. So deadline is slightly different from last week. So it's changed but extended. So the deadline is today, 12:45. Today, 1:45. We have done with like area, volume, round off, and we're going to some differentiation of some nucleus at the center of the atom. So the story of the nucleus. It's quite basic things. Maybe you have already learned when you were high school student or maybe junior high school. Yeah. So stories like protons, neutron, and atom, and electron, etc. Yeah, like atomic orbiter as well. So this is animals, and if you divide these animals into tiny parts, first you're going to see the protein. This is a protein, and protein is made from molecule, and molecule is made from atoms, and atom is from atom, nuclear, electrons, nucleus are from proton and neutron, and you can divide these proton and others into particle elements as well. So I have not so much knowledge about particle elements, and particle elements name is like up, down, strange. These two are cork, charm, top, bottom, whatever. I do not know yet, and so a lot of elementary material, elementary particles, and in fact, I'm professor. I'm teaching here in Shizuoka University. Also, I am teaching in Thai University. The lecture title is supermarket chemistry. So maybe they are quite new word for you, supermarket chemistry, and I am going to explain what is supermarket chemistry. I am teaching in Thailand University. I'm going to show you something. The Thai is Japan here, and Mamatsu must be around here, and you could fly from Nagoya to Bangkok, and this is Bangkok, and the university I am teaching is here. Course Rayon. This is Bangkok, Rayon. You need 2 hours driving from Bangkok to the university. A couple of years ago, I brought my students. Those days, the Chubu Airport, Nagoya Airport, is quite windy, and just before we are taking off at the Nagoya Airport, and sunny day but windy, like going to Hamamatsu. These guys are students those days, and you can recognize my shadow here. And Thailand is quite violent. The site work, their two priests are working with barefoot this way, and this is not unusual, just daily life here. There's many priests of Buddhism. You can see the traffic sign, the red sign, and the figure is quite tiny, so I zoomed up here, but it looks like elephant here. The traffic sign said that caution, elephant crossing. So there are many elephants crossing the road. So sometimes you hit elephant. Maybe the elephant hit you. So I don't know which damage both of you going to have. But traffic sign in Thailand this is common as well. In the university I am visiting, it's called Vistek. Show name is Vistek. You can see the university name here, and first, those are acronyms. So Vistek, V is it's Sanskrit word, so I cannot pronounce. This Institute of Science and Technology Institute, or something like that. One of the symbols is second football molecule of C16. In front door, there is a monument of the C16. Also, you have some, this is the name of the university, Institute of Science and Technology, or something. So this V is Sanskrit, named after princess of Thailand. So here, I could not pronounce the Sanskrit. In the university, other symbol is this. This is just hexagonals. So last one is C60, but this one is carbon nanotube molecule. So these are building of the university is brand new, and you can see the pond, but this pond is artificial, and around this university, nothing, almost nothing. You can see it's only forest where elephants are living. So no one meets the elephants, but it's quite dangerous. But it's not this is not zoo, so the elephants are just wild elephants. But at present, Thailand just completely count the number of the elephant. But these days, someone killed the elephant and take the ivory, and ivory makes a lot of money. So any elephants has at present GPS and controlling everything. And this is my friend, Thailand Professor Gawa, and my students and Thailand students are this first night. And the other Thailand professor, Surya, I think I'm going to see these two guys this August in Canada. But we do not yet, the airplane is going to launch or not. So maybe yes, maybe not. This is the cafeteria. You can see this in around the cafeteria. You can see the pond, and yeah, it's quite green. And everybody, students, professors, other administration workers have breakfast here and lunch here and dinner here. So all the time you're here. So after 1 week, everybody knows each other's. So I visit here just once a year, but in the cafeteria, finally having the meal, everybody called me, hey, Mr. Tanaka, Professor Tanaka, how are you doing? Something like that. So the quite tiny university. I guess number of students are less than 500. Yeah, just lunchtime with here. I had lunch, and I was having lunch with students, and at the end of the lecture, a morning lecture, students come to me and go to lunch together and having lunch together. Lunch is like this, like yeah, on demand. So buffet, rice and some meat, whatever you want, you can take. And maybe you have fish salad. And this is my plate, a lunch. It looks so nice and it tastes also very nice. So you always have to beat them overeat or something. This is quite interesting picture. And this side is tables, and this side is they're making kind of salad. But this salad is, can you recognize that here? There's a piston and motors, and they are putting some fresh living crab into here and smash the crabs this way. Not only crabs, but they put some vegetables and others. That's a product of the salad. So that means ingredient is fresh vegetables and smashed crabs, smashed raw crabs. Tastes extremely good. Not picture of the product, but it tastes very good. But Professor Ogawa said, I guess maybe 1/3 of people having this salad get some sick on stomach, even for the Thailand people. My case is no problem. It's very nice. So a bit risky salad. Yeah, lecture something like that. So I'm teaching some experimental chemistry, but some very much biomedical science, biochemical science. And this is after lecture. These real professors there, and their students, and the lectures were only 2 days. So the first day, the morning, afternoon, only 4 sessions. So but quite complicated, quite concentrated lectures for 2 days. This is the university, and yeah. So I am teaching in Thailand. I'm teaching about sperm-molecular chemistry. What is sperm-molecular chemistry is like you have a molecule, but even if you have a molecule, some specific weak interaction between molecules and molecules or intermolecular as well. It requires. So it's quite weak interaction, but you need some 3-dimensional structure of the protein and others. Those 3-dimensional structure, you need some weak interaction between like molecule and molecule, or molecules and molecules, inside of the molecule and between molecule as well. So weak example of the weak interaction is like hydrogen bonding interaction, electrostatic interaction. Electrostatic interaction is plus, minus with drawing force, and others are van der Waals interactions and the hydrophobic interaction and so on. Those chemistry covers, those are sperm molecule chemistry covers those areas. Weak interaction makes some elaborate, very much complicated structure. But complicated means just follow the DNA information. DNA knows, your DNA knows some weak interaction as well. So three-dimensional interaction is already written in your DNA. So at the beginning of the sperm molecule chemistry lecture, I've been talking of like mice, protein, molecules, atom, and the neutron, electron, proton, and some elemental particles. Like so, I am focusing on the not up, not down, not strange, not churn, not top, not bottom, neutron. No, neutrino. Neutrino, yeah, this one, neutrino. Again, this is the elementary particles. Like you can divide, you can smash down the neutron and nucleus, and you have proton, electron, and others, and finally you can get some elementary particles. And I am talking of this. Where is neutron? Where is neutrino? Yeah, this one, neutrino. Yes, you are a graduate student, so you have to. You already visited this part in this campus. Have you ever visited the Takayanagi Museum before? Answer me by chatting, please. So if you say no, before graduation, you have to visit the Takayanagi Museum, which locate in this campus. In the museum, you can see that these photon multiplier tube, huge one. Its diameter is like this, close to 1 meter, I guess. Yeah, this afternoon or something like that. Right after this lecture, right after you have complete your exercise and submit exercise, you just visit Takayanagi Museum, which is close to the south gate in this campus. You can see the photon multiplier tube like this. For this is FAT. This is a device which convert light into electric current, light to electric current. I think vice versa is possible. So vice versa means a device from electric current to the light is just lamp. And this is especially the vice versa, light to the electric current. Yeah, it's the same way as some semiconductor is functioning same like charge coupled device or hot transistor diode. It's functioning same imaging plate or something. And especially this is for the used for neutron detection and the cause Kamiokande, old mine, and so old mine has a big hole inside of the ground. So they place these photomars into the hole and covered with water, and to catch the neutron from the scuba. Scuba has a neutron gun and the chute, and they catch a neutron here, and they detect neutron and tell whether or not neutron has weight or not. Finally, the experiments show that the neutron has weight. So the old Kamiokande has almost 1,000 this photometric cryotubes, photomers. So 1,000 means 1 meter size, and 1,000 number of 1 meter size. And the present one is 11,000, and present building one is almost 100,000 photomer is here to detect the weak something particle, elementary particles. So this is Hamamatsu company, Hamamatsu Photonics, and which gives the 2 Nobel Prizes in 2002 and 2015. You maybe remember Professor Koshiba and Professor Kajita get Nobel Prize, the different year. That reason I am talking for, this is kind of introduction of Hamamatsu in Thailand lecture. What is Hamamatsu? Hamamatsu is like we have Yamaha, we have Suzuki, and also we have Hamamatsu Photonics, and Photonics produces photomers, and photomers used for detection of neutron and others. So here in Thailand, I'm showing this slide, and also I am showing this slide to you because of, if you do not visit yet, yeah, you should better visit this museum. Excuse me, I'm sorry. Maybe at present it closed as the virus effect. I'm sorry, but I'm no idea. I'm sure it closed. So the coronavirus ceases when ceases. They just visit this museum. I'm sorry. Yeah, it should be closed. So we're going back to the scientific pronunciation and quantum numbers. I think we have already learned, maybe high school or university, quantum number is just not familiar, but you just know what is quantum number is. First, quantum number, the symbol is tiny m, italic tiny m. And the Marshall quantum number, L. This means like a direction quantum number. And third one is symbol tiny m, italic tiny m, magnetic quantum number. And last one is spin quantum number. Only you have these things, you have just plus, or only you have 2 choices for the spin quantum number. Oh, let's say right-hand side spin or left-hand side spin. Only 2 choices here. Only you have. So shell means, yeah, you already know this word. K shell, L shell, and shell, and shell. So just I use English, and you know this word. You may call that shell. So this is a table indicating the shells and others, and quantum numbers. Named the shell K shell, L, M, N, and first quantum number is just 1, 2, 3, 4. You know already. And then n squared times 2 equals numbers. The shell could numbers of electron numbers. The shell could could take possess. So K shell, you have 2 electron, L8, M18, and M32. And if you're going to see the subshells, maybe the other word is orbital. Electron subshell or atomic orbital. S orbital, P orbitals, case of the L shell, you have S subshell and P subshells. In the other word, 2S and 2P, and this is 1S. And N shell, you can have the 18 electrons, and we have subshells of SPD. That means 3S, 3P, and 3D. So 2D and 1D, those do not exist. And here we have F subshell, F orbital is here. Yeah, this again table. This side is subshells, and we have changed this one is direction quantum number L. So the L 1, 2, 3 in electron number we can take is for S subshell into 6, 10, 14. We have already known. So magnetic quantum number is, as you know, this is from the given you by this equation 2L plus 1. So for S, 0, and P is 3 chances, and D is 1, 2, 3, 5. I can write Fe here. So these were subshells and shells and orbitals you have already learned. Just you don't know the word. This is shaped with S orbital. P and D. 1, 2, 3, 4, 5, 5 kind of D and D. Yeah, this 1, 2, 3, 4, 5. 5 Ds. This is F. Quite complicated here. So the F is like rare earth, rare earth elements closely related to the F orbitals. Maybe other very much common molecular orbital, no, atomic orbital is sp3 hybrid orbital. You may call that hybrid. And in this way, we call that sp2 hybrid orbital. Yeah, these are like prior to explain what is supramolecular is the basic is the elementary particles, but I do not well yet. Just this is Hamamatsu. You are studying Hamamatsu, so you do you should better know what is Hamamatsu city. And, in fact, the professor Takayana, you can his studio just when you come into the front door. At present, left-hand side of the unit, you can see his studio. And Professor Takayanagi, he's a kind of the man. He invented the TV system, the first guy in the world. And after Professor Takayanagi, the people, his student, made the company, which name is Hamamatsu Photonics, and those technology is now contributing the particle, elementary particle detection around this part, neutrino. So, and we going to this way, and molecules, not directly to the animals, but between molecules, interaction between molecules and intramolecular interaction, those are very, very much quite important. And those weak interaction chemistry is supramolecular chemistry. But the student taking this lecture is not only taking the molecules, but also you're taking some solid. Solid state is a bit different, story different. Case of a molecule like the occupied and high energy molecular orbital is called the HOMO, or and unoccupied, a vacant one is the lumen. This is molecules, but case of solid, story a bit different. You have to explain with the band structure, energy band and vacant band and contribute band. I guess this is an insulator, a conductor is just a closed conductive band and valence band. Semiconductor is this way. Yeah, the board, the middle part is called that ferromagnetic. In this case, it's exact the same. Difference is just this. The results of degeneracy of orbitals. It's these solid states, so these are shrinked, finally taking the same energies, this part as well, and you can get some not molecular orbitals. Instead, you have some band structure in the case of the solid state. Yeah, because of the orbital degeneracy happened, so which makes band structure. So originally you have some many molecular orbitals here, but it's now almost same levels, and yeah, to make the band structure. Yeah, so someone answer me there. What is this? This is not cake. Answer is here. And I'm just put some white seed on it. Someone could give me the answer by the chatting. What is this? No answer? This is the, yeah, of course. You should know the word. Yeah, this is in fact the, yeah, periodic table, but this is in fact birthday cake. I think this is girl's name, Samuel. Happy birthday. I don't think boron is here. I don't think hydrogen is here. So the this is the periodic table. Thank you, Mr. Ono. Yeah, Ono-san, arigato. Yeah, this is periodic table. You're correct. So your periodic table. This, yeah, in fact, your birthday cake looks so nice. Yeah, last time I showed the picture from the Thailand. This time I'm going to some pictures from Canada. Here, Vancouver. This is the United States, and LA, Los Angeles is here. I guess still locked down. LA, is that true? And I know San Francisco, and New York is something like here, New York. And the story is Canada, up north, and this is Vancouver, quite familiar name for Japanese, Vancouver. We have this, last time we visited the Thailand, and this time we have visited the Vancouver. Again, a friend of mine, this guy, last time, Professor Gawa is my host, and Daniel Rezunov. Danny is our host, and he belongs to Simon Fraser University, and he also belongs to the Simon Fraser University Department of Chemistry. So chemistry department professor he is. He's trading the gold, and that's the reason his jacket has some gold elemental symbol here, and it says chemistry. And this university is quite unique. The chemistry department has periodic table, but this periodic table is on the board. It is a periodic table, but anywhere the real materials are here. So manganese is here, chromium is here, iron here, and some of those are compounds, but everything is here except radioactive element. So everything here, yeah, weak radioactive element is, yes, still here, but strong radioactive elements such as atom, such as like uranium or no. So the everything is here, quite unique periodic table. And you can see here, boron, and I just focus the boron. Danny's face becomes so huge, but you can see the boron, and this is boron compound inside, but this is says Greece, and Tamiya trademark is here. So this is from Tamiya, and which is Greece, and I think it contains boron, and they take the boron. So I told Danny that, hey, Danny, this is from Shizuoka. This is some company, Tamiya is not Hamamatsu, but Shizuoka City company. So it's quite well known. So that's the reason you have chosen something. Periodic table in Simon Fraser University has some product from the Tamiya. Yeah, this one. This is more clear. Tamiya. Yeah, Tamiya and Mabuchi is quite common in the world. So somebody do not know the Tamiya and Mabuchi from which country or which city. In fact, it's Japan, Shizuoka. This guy is very much involved in chemistry in Japan. And in fact, his wife is Japanese. And look at his car. These were, those days, my students. And look at his car. He owns a Corolla. And look at this, his number. In Canada, you can choose your number plate. And his number plate, look at this. Chemistry, but in Japanese. The name of the province, like state, Vancouver, not Vancouver, Burnaby is British Columbia. So in British Columbia, there are the two big universities. One of those is Simon Fraser University, and the other is University of British Columbia. And he's a Simon Fraser University professor, and his number plate is, Kagaku. Yeah, quite interesting. Yeah, this is his car. Yeah, this is a story of the particle element and periodic table, and those words, you should remember those words. In the next point, accent and pronunciation. And I'm going to tell you that when you talk in English, of course, pronunciation is quite important. But I think rather than accent is quite crucial. Accent. So if you do some correct accent, and if your pronunciation is wrong, sometimes it works. But correct pronunciation and wrong accent, generally it does work. So accent is, I think, much more crucial than pronunciation. Those examples, I have already shown adverb accent here, quite strange. You would pronounce this as adverb. In fact, the accent here is adverb. In this way, same way, it's like adjective. You would pronounce this as adjective, wrong. Adjective. In this way, Disneyland, no, not Disneyland, Disneyland, top here, we have accent, Disneyland. I'm doing science of the battery and capacitor, science and chemistry, and capacitor is capacitor. Not capacitor, no. Capacitor, transition here, and again, this capacitor, A pronunciation is like same as cat. Oops. Cat. I tried to write this, and of course it doesn't work. It should be on my iPad. But yeah, A pronunciation, A. Capacitor. Oops. Oops. Neglect. This is coming from my mistake. When I was 20 years old, first time I visited United States, my uncles and I was talking with my cousin, and I pronounced this as neglect, but he doesn't understand. Yes, sir, you would like say neglect? Yeah, so I made a mistake of accent. Pronunciation, I guess, correct. Neglect, neglect. Not neglect, neglect, neglect pronunciation. This is coming from my mistake. Neglect. This saying, this is kind of from my mistake. Indianapolis, Indianapolis, Indianapolis. A pronunciation again. A. Indianapolis, 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 Indianapolis. So maybe you would like pronounce this as Indianapolis, but Indianapolis. You need accent here. Yeah, map again. Those days. This is a point of Chicago, and this is Indianapolis. And I direct fly from Chicago to Indianapolis. So I'm going to try to buy the ticket at the airport of Chicago, and I asked a lady, career lady, I would like to go to Indianapolis, Indianapolis. So she doesn't understand. I pronounced for many times, but Mister, would like to go to Indianapolis? Yes, that one. I repeated Indianapolis, but she said, you pronounced me Indianapolis. That's the reason I don't understand. Yeah, she was quite correct, and Indianapolis accent is quite crucial. So Indianapolis is something like here, quite middle part. And no, Chicago is here, not A. Chicago is here. This is Indianapolis. A is finally I visited Purdue University. Purdue University is here. Chicago, Indianapolis, Purdue. Yeah, like that. Okay. Disneyland is same. I guess Japanese Disneyland is same as a situation the same as the China Museum at present close. Inside Japan, you have Disney Sea and Disneyland in Japan, but in Shanghai or Hong Kong, maybe opened already, or I'm not sure, but story is Disneyland. Maybe exercise. No, not exercise too. What's it? Do you know the English word of the story? So you know the Japanese name, but after this, maybe it will be better. Be familiar with some English title. Namely, it's Snow White. Her name is Snow White. The exact same as Japanese name, Snow White and the Seven Dwarfs. So it's exact same, just direct translation from the Japanese and from the Grimm brothers. But this is at present, this cartoon belongs to Disney. The next one is four animals: hawk, cat, dog, and this is not horse. I think this is donkey. Do you know this story? Town musician of Bremen. Bremen is the name of the city in Germany. The musician of Bremen, but Grimm brothers. This is also Grimm brothers, but this is not belong. This doesn't belong to Disney. This is independent story, but from the Grimm brothers. In Bremen, we have this kind of city or these stories. I think this is Bremen, and Berlin is, yeah, here's Berlin. So Bremen, and I think this is the other city. And I used to live in, we are here, Strasbourg. I used to live in here. I'm working for the University of Louis Pasteur here, and I used to work here. And yeah, Frankfurt, capital, Bonn. Where is I? This is Bonn, and the biggest city, Berlin, is yeah, something like, yeah, yeah, here. And this is Bremen. Yeah, Bremen. So I guess the story is something like any animals usually they are just work for a owners. So but they becomes all old. So the owner just kicks away them kicks away. So so they have finally these four animals have no house, and others they're just walking, and they just gather and make some music band or something like that. This is a story. And this is Bremen, and the Anton is B is like this one. He's playing pipe, so you may call that piper. And something interesting is intriguing is like he's rolling some stripe crows. So striped crows, you may call that pied wear. So the story name is Pied Piper. Yeah, this is also from the Green Brothers, but doesn't belong to Disney. But Pied Piper. It says this is not just story, but it's in fact happened in 1284, June 26th. I guess story is something like that. The people town is these people are asked him to kill any mouse in the town because the mouse eat everything, the food and a building and others. They asked this guy. He's like he can control the mouse and animals by piping. So they asked this piper, and he just kidnapped the mouse, and he asked these people the money, but before his kidnap, these people just they say that if you just clean up the mouse, just we're going to give you this money or something like that. That's the reason he asked money to them, but they do not pay. They don't pay. So this piper gets angry with them, and next, not mouse, but he piping, and any children disappears, like kidnapped. But the story says that piping makes the children, just running and just run away from a town or something like that. So finally, just they were quite unhappy because their child completely disappears. After that, we do not know. But it says like, this is coming from the story, truth. In fact, really happened. So I guess not piping, but in fact, the kidnap happened or something like that. Real kidnap happened. So after that, the Green Brothers make a story or something like that. I'm not sure. Yeah, this is not Bremen, but in the town, happened the town is Hameln, around here. Tiny town, Hameln is tiny town. It's not on the map. Yeah, almost. Yeah, I'm talking about Disney, but Tiny has close to the past 10, so yeah, some part left. But yeah, maybe just a skip for next week. And exercise two. Exercise two. Right. First, exercise one is I already told, and exercise two is explain the difference of elements with atoms in a few sentences. Yeah, this is today's exercise. So deadline is I told 12:45 today by email. Yeah, that's it. It's over today. Next week.